afternoon. Good afternoon. Thank you. My name is Blaszczak. It turns out that I'm some sort of developer code monkey kind of guy on the Visual C++ team. I work at a company called Microsoft. Perhaps you've heard of us. We're really big in pharmaceuticals. Today I'd like to talk to you about how you can use Visual C++ and some of the libraries and some of the APIs that ship with it to write cool internet applications. We have a lot of slides to go through today. I have about 61 slides, which means that we're going to cover material at the alarming rate of like a slide and a third a minute. Okay, so I'm going to go pretty quick. If you have any questions at all, please do this. And this is recognized by the Coast Guard as the International Sign of Distress. I'll stop the talk and answer your question. After a point probably in the talk, I'll realize that I'm nearly out of time and refuse to answer questions, and then we'll hold questions until the end of the talk. Okay? And at the end, just line up behind one of these two microphones here. That's microphone A, and that's mic B. But wait, I'm mic B. And we can take questions at the end of the session there as well. Okay? So the agenda today, we're going to talk a lot about how we can do things on the server side. I'm going to demonstrate ISAPI. I'm going to talk about how to write an application in ISAPI. I'm going to tell you what ISAPI is all about. We're going to also go over to the client side and talk about some of the WinINet APIs and explain how you can do things from the client side. What happens on the client side when you want to get or put information to a web server or to an FTP server. And then we'll have a couple slides on how all this might tie in with HTML. So that's a little bit more information about the server side. About the client side. We'll talk about some integration that we have forthcoming in Visual C++ 6.0 and a future version. And from there, I'll give you a call to action about how to write applications using Visual C++. Sound like a good plan? For weeks before this conference, I worked hard on these slides. And then I leave my girlfriend and fly down here and hang around all week. Okay, thanks. You people are the wind beneath my wings. What y'all do last night? You seem pretty tired. So I went down to watch the Avalanche game. Anybody else go to the Avalanche game? No? They did terrible. The question was, how did they do? Well, they did terrible. 3-0 shutout. I had nothing to cheer for, so I just concentrated on the beer concessions. Okay, look. On the server side of things, we're going to talk mostly about ISAPI. We're going to talk about filters and extensions that you can write with ISAPI. I'm going to give an overview of what ISAPI is all about. We're going to write some sample code right here on the stage, right here, right now, right in front of you. It's amazing I never leave my office. First, I want to start out, though, by discussing the HTTP model. Exactly how does it work? Like, when I sit here and say client side and server side and client side, what's actually flowing between them? What's the protocol that's going on between them? And as much as you might use a web browser, as much as you might have dealt with these technologies in the past, you might not fully understand exactly what HTTP really means. And you really, really need to understand HTTP. If you want to take any of the techniques that I'm going to demonstrate today and customize them for yourself or aggressively use them for yourself, you will need to understand HTTP. I will provide a very brief overview in the next couple of slides. But at the end of the talk, you'll see, please turn to page 3 and then select. At the end of the talk, you'll see a resource that says, look, go look at w3.org and find that website and go download the HTTP spec. And it's a lot of thick stuff to read. But if you can understand that document, you can get through that document, you'll really understand HTTP, you'll understand how it can be made to fit the things that you need to do in your applications. Okay? And we'll have 2 slides on HTTP, so if you already know it, just bear with me. After that, we'll really get down to business with the rest of the technology that we wanted to talk about today. So the HTTP model, right, involves 2 machines. First, the client. And the client says, geez, I have a request. Maybe I'm running some application that's going to make a request to the server, or the user's walked up to the web browser and said, geez, I have some request to make. I want to be able to do something, or get me a page, or let me see some stock quotes, or something like that. So you connect to a server. Once connected to a server, the client sends the server a request. So the server is now listening since that connection is open. and the server decides, geez, let me look at this request and see what it's all about. It responds to the request, the client reads all that data, and the server probably disconnects. And you see it like disconnects on the slide with a question mark after it. And that means that's actually there because I don't know any of this stuff, and computers are really hard, and I'm not really sure whether it disconnects or not. Does anybody know? So it turns out that the server will actually optionally disconnect. So if the client request says, I want to make this request, period, the server will respond to the request, the client will read the data, when it's done reading the data, the server will drop the connection, and that's the end of it. However, it's possible for the client to express some options to the server and say, look, server, I want this information in this format, I'll accept this type of encoding, I want this kind of language. I'm more interested in English than I'm in French. Well, if Japanese is available, Japanese is better than French, of course. So it's something that lets the client really customize what it does to the server. And the server is expected to understand everything that's in that HTTP spec. There's a tremendous amount of options. One of those options is called keep alive. So the client can make a keep alive request to the server. And the client will say, look, I have a request, please fulfill this request, but when this request is done, do not drop the connection. And that's a very, very important optimization because the client can say, geez, I know I'm going to get 3 or 4 or 5 or 6 or 10 or 3,000 things from this server. So why get, disconnect, connect, get, disconnect, connect, get, disconnect? Instead, let me get and get again and connect only once. And of course, connecting involves a lot of overhead. You know the name of the server, you have to go find its address. You have to find its address and you send out some network packets to start getting some routing done. Get some routing done, you might finally connect. Once you finally connect, then your query can go through. So by eliminating things like that, you can tune the way the protocol works to your specific needs. You'll generally find that 2 things happen in HTTP. One thing deals entirely with formatting of data. Should I ask for this in French? Do I want a GIF file? If I ask for a GIF file and only a JPEG is available, do I still want it? Maybe I don't. And if I don't waste time sending it to me. Because I just don't have time for that other kind of format. On the other hand, there's a few options that will dictate exactly what happens to the protocol. If somewhere in between someone has inserted an extra tier, like a proxy server or a firewall, you can also add things to the request that determine how the proxy wall or the fire server 3-0. How they respond to the request as well. Are they allowed to cache it? Must they always refresh it? Do they convey the same security that you provided, or do they ask for different security? So on and so forth. So HTTP in a nutshell specifies both what you're asking for, how to get it, and what to do with it as it comes back. All of this is done via headers, and I'll make a very simple example of how this works in just a second. But what ends up happening is that both the request and the response will contain headers that describe the data that's going back and forth. Okay, so let's take a look at exactly how that works. But what I'll do is I have 2 computers up here. Well, I have 2 computers that I know what they're doing. And what I'll do is just go over to, go away from my presentation and go hit my internet information server up here. They gave me a whole server to myself. Unfortunately, it's not called Mooseboy, but what I'll do here is use Telnet, which ships with Windows and ships with Windows NT. You can go home and try this yourself. You can't come up here and try it. And what I'll do is ask for a connection to my server. My server is called tool003, and I'll connect to port 80, and I'll get a connection. Okay, there we go. So what I'll do now is type in a very simple request, get/. And that's a very archaic HTTP format. It has, there's lots of extra options I could add to this. But what this will do is get the / object, the root object, from tool 003. And I'll hit enter, and there it is. So that's raw HTML that just came back to me. Okay? Now, since the Windows Telnet client is kind of crummy, it's kind of hard to scroll around. So what I'll need to do is start logging. I'll connect to that machine again, and I'll offer a little bit more interesting request. So I'll say get the / object, get the root object. So this is the same thing as getting a web browser and saying, look, I'm going to walk up to that server and connect to tool003/ in the address line. So tool003 in the URL says that's the server I want to talk to. The / is the object that you want. if you connected and got index.html, that would be tool003/index.html in the URL. Here I would type get space slash index.html space HTTP WAC 1.0. And that HTTP WAC 1.0 indicates that I think I know how to parse HTTP 1.0 headers. And there's going to be HTTP 1.1 headers, and there's going to be a new version of HTTP after that. So this is a way that clients can say what they're good at or what they're capable of sending or receiving or getting or putting back to the client. Okay, so let's hit enter on this guy. And nothing happened. And the reason nothing happened is because the server realized that I said HTTP WAC 1.0. And in the previous request, I just hit get space WAC enter. The server is going to default to HTTP version 0.9, where I'm not allowed to have request headers. So the server knows I'm not going to ask for anything else, and it doesn't listen to it. So I need an extra new line there before I get my response. Now I've gotten my response. I'll stop logging. And the reason I stop logging is because I'm worried about spotted owls. And what I'll do is take a closer look at the session text that I received. And hopefully, well, actually, let me bring this up in WordPad. Since WordPad is, after all, an NFC app. Okay, so what I've gotten here is my response. And you can see that where I said get HTTP 1.0. And this is what Telnet logged for me. Excuse me? Oh. So what ends up happening here, this is what I typed in, and that got logged as well. So we can just delete that. Here's the response. The response says, look, I did respond with HTTP 1.0, and it turned out your response was okay. And if I got some different response, if I asked for something that didn't exist, I might get an error message here, right? I would have some code, 404 not found, 501 server configuration error, or something like that. After that happens, these are response headers. And these response headers indicate information about the server, information about the content type that I'm actually receiving, indicate information about everything that I've done in the query. When was this guy last modified? Do I need to knock it out of cache? So on and so forth. How long should I expect the content link to be? All that information comes back in headers. And then, finally, after that, here's the actual HTML that was on the server. And the actual HTML just ends, both because the connection is closed and because I know that I received n number of bytes back from that content link guy. Okay. Now, it turns out that HTTP, that specification that I mentioned a couple slides ago, defines exactly what all these things mean, exactly what's going on, exactly what is going to appear in that header, how the data should be formatted, is the number of bytes or the number of characters, does it include new lines or not, what things am I allowed to have here in content type, if I wanted content type to be a WAV file, what would I actually put in there, so on and so forth. Now, what we'll talk about today is ways that you can deal with these headers, and ways that you can send those headers, and ways that you can modify them as they're going back to you. But also, bear in mind, you can do two things. One, you can stick to the HTTP specification and try to get HTTP to do what you want. Two, since I'm going to show you how to write server extensions, and I'm going to show you how to write client-side stuff, it turns out that you can write your own clients that use special headers and write server-side thingies that parse those headers and understand what they mean and come back to you with information that your client expects. Now, obviously, that makes things proprietary towards you, but HTTP is extensible. You can get away with doing that kind of stuff to extend the relationship between the client and the server, to make things customizable for you. And you can ride on the back of the HTTP model. And certainly, since you can do both client-side headers and server-side headers, maybe you can continue to have a more open system by looking for the client-side request header. So if it's your client, maybe it adds a header that says, hey, I'm a client that you wrote, please recognize these extra headers. And the server will say, geez, that header means that I'm allowed to talk special lingo to this client and let me make my response along those lines. Otherwise, on the server side, if you don't see that special identification applied line, maybe you can make a more generic response. And that way you'll have backward compatibility to people who visit your site with a web browser or with other tools that aren't compatible with the special things that you embedded. Okay? So let's get down to the nitty-gritty. Let's get down and see how exactly we do this. All right. So you'll hear people talk a lot about internet applications, and to me, at least for the purposes of this talk, internet applications mean two things: active clients and active servers. And everything's active, so that's why that's there. Thanks. So it turns out active clients are going to end up being the things that we're going to write today. We're going to write some clients that sit around and say, look, let me use Windows features to go talk to the internet. Active servers are going to be extensions that I've added in to my server that run all the time on my server, that ride on the backbone of the power and the flexibility and the scalability of internet information server. And the way that we do that at Microsoft is with a protocol called ISAPI, Internet Server API, ISAPI, ISAPI. Okay, everything ends in API. Pretty soon it'll be Wake Pappy. Please fill out the server or the speaker evaluation forms on your way out, by the way. So this specification, ISAPI, gives us a way to add functionality to our web servers. We can use this functionality, if it's supported by our web server, to provide extensions and filters. Extensions allow you to place custom, well, actually both of them allow you to place custom code on the server. In a nutshell, extensions are run on demand when someone asks for them, and filters are always there, and they have the opportunity to see everything that happens with any particular request, which could be a whole ton of information, especially on a busy server. So let's take a look at how to write those guys and exactly what they need. By the way, ISAPI turns out to be an extension of the CGI standard. If you're familiar with CGI, you know that there's a way to write server-side software that executes. The server says, oh, geez, I got a request for a CGI thingy. And the server says, well, look, let me spawn a new process. Let me run the CGI thingy in that process. Let me shut down the process and take the standard out from that process and blast it back to the client. Well, that's slow because it was invented in Unix. So what we've done is afforded them. You know, I bring this up every time I talk. I do talks all over the place. I mean, I've done dozens, internally, externally, all the time. And when I say stuff that's funny, nobody laughs. And when I say stuff that's not funny, everybody laughs. And I can't figure it out. So popular active servers are really right in front of us. I mean, it's very common to do these things, right? You can imagine that there's a lot more than static HTML on the web. You know, you go to websites and it just blastbacks a page or blastbacks a picture or blastbacks some stuff that's formatted nicely. More often than not, these days, what you're seeing at sites like Amazon.com or BarnesandNoble.com or whatever your favorite site is, are server-side things that are generated dynamically, meaning that you send a request to the server, and the server doesn't have a canned response for that request. It has to go hit a database or a temporary file or look something up in a catalog and then formulate a response based on what's in that database or what's in that file, and then blast that back to you and get it formatted into HTML so that you can see it. These servers are really interesting. I mean, it breathes far more life into the web than what you can get with static pages. So by writing extra extensions, not only do you have the ability to extend the relationship between your client and your server, you have the ability to provide far, far, far richer content from the server. So these executables are executed on executables that can be executed on the server. Like water ballet is ballet in the water. Just go to the server and request a very special URL, right? So if you have a server named Mooseboy, like I do, then you can request whack register.dll. And if I walked up to Mooseboy and said, look, just give me Mooseboy whack register.dll, it would give me the binary file register.dll, which is not so interesting. But if I put a question mark after that item, I am now instructing the server to load register.dll and run it. And everything to the right of the question mark ends up being stuff that I pass to that extension as a command line, if you will. So now I can get input and get output and maintain state and have kind of a conversation with my web server. That extension runs, it sees all the headers, it sees all the information that's going by, it sees everything that you're interested in. You can parse that stuff, you can react to it. If someone connects to you and they're using Netscape, you can deny their request, or if someone's connected to you using Internet Explorer, you can service their request, whatever you need to do. Right? They come to you and you don't like their username or their password, format their hard drive, anything that you need to do in response, okay? So these guys turn out to be implemented in DLLs. And you saw that, I kind of took that off, right? Register.dll, that probably means it's a DLL, huh? Yeah. So since it's a DLL, the ISAPI specification defines that it has a couple of distinct entry points. Load this guy and execute this guy turn out to be the two. It's loaded on demand. So if I turn on the machine and start up Moose Boy and its Internet Information Server fires up, register.dll is not loaded until someone connects to Moose Boy and asks for register.dll. Once register.dll is loaded, it stays loaded forever until Moose Boy goes down. And when that happens, then the server gets, then the extension gets unloaded, then the server might, will free it as a part of its shutdown process. It's possible that in the future we'll kick servers out, extensions out of memory for space tuning or work set tuning, or there might be an administrative tool to do it someday. Right now, that's not the case. They're just plain old in there forever. The extension DLL is multi-threaded and re-entrant. So if two people at almost the same time walk up to Moose Boy and ask for register.dll, register.dll will be entered more than one time at the same time from multiple threads, which means that ISAPI programming is multi-threaded programming, and multi-threaded programming is not easy. So you need to make sure that you understand the fundamentals of internet, of multi-threaded programming. You need to make sure that you understand why global data is bad, bad, bad. You need to understand what things that you're going to go talk to are multi-threaded as well. Can I go talk to DAO? Maybe, maybe not. It depends upon if you have a version that's multi-thread capable or not. Okay? Threads enter and exit that guy since it's sitting in memory. Always multi-threaded. There's no way to say, look, I wrote a bad DLL and I only want it to be entered one at a time. Okay? It's always, always, always multi-threaded. Active filters turn out to be a little bit more, mostly the same idea, but a little bit different. They allow you to implement things like security or do access logging or do translation on the server, implement things like virtual directories, so on and so forth. They're very, very useful for some of the things that I list on the slide here. Active filters are implemented also as a DLL, but they're implemented as a bit different style of a DLL. Okay? The DLL that you use for a filter ends up being a DLL that is loaded by the server as the server starts. The server will not respond to requests until all the DLLs that have been successfully loaded initialized. There might be more than one filter DLL on a given server. And as soon as a request comes in, the filter DLLs start hearing about it immediately. Now, when a filter DLL loads, it says, geez, it can say, geez, I'm interested in this kind of notification. Tell me when someone connects. And I'm not interested in seeing every byte that gets sent, but I'm interested in seeing every byte that gets input to the server. Okay? So the filter can ask for very specific things and receive notifications based on the notification request that it is registered for as it loaded. It cannot change its mind about what it wants to receive after it's been loaded. When more than one filter is loaded, the server has some rules to decide who gets notified and when. So you can imagine that, if you're an old timer like me, at the ripe old age of 28, you can imagine that server filter programming is a lot like writing TSRs. You say, geez, I want to hook the keyboard, and I want to be the first guy to know that someone has pressed the key. And I can say, geez, I see that key, I don't care about it, pass it on to the next handler. Or I see that key and I want to do something about it, but pass it on to the next handler. Or I see that key and I want to do something about it, but don't pass it on to the next handler. Filters work in very much the same principle. We're just processing notifications that can get hooked up, that can have default behavior, or might not. So you're in bed very much with the server. Now, I made a huge sweeping statement about, and probably cheesed off the Linux crowd in here, but the reason this is more efficient than what happens with, you do talk, so you watch the whole audience, right? And the whole audience is a huge group of people, right? So just because of the numbers, like weird stuff can happen, right? And you think, like, I'm a parent, I'm a professional, mostly, and I just, like, I can overlook some things, right? Like people with green faces because they're playing with their laptop. What just happened now that totally derailed me was that some guy got up and left, which is fine, but he walked straight through a door that said not an exit. Those are the kind of people who run around calling terminate threads and stuff, right? It seems to be leaking. I don't know why. So where was I? It's like just looking at it, it says not an exit, not an exit, not oh. So the reason that this is more powerful than the CGI solution, I mean, first off, you have filters, right? Filters just don't exist in CGI. The other reason that's more powerful is that this multi-thread in-process thing is happening. So these guys load, and they really are server extensions. They really are in the server workspace, right? They really are living in that same area. So when you spawn a CGI extension, you're spawning another process, and processes are big, fat, and huge, like me. Plus, they're very hard to communicate with. So what ends up happening is that you open standard out, you send it some information through standard out, you set some environment variables, CGI thing looks at that and then pumps the standard in. So now you're screwing around with all these pipes, you have extra temporary data lying around, and you kill the process, and processes are expensive, so they shut down, expensive as well. Then you get all this information, and it has to jump the process boundary, and now you have it in a buffer. Then you take that buffer and blast it back. Well, Internet Information Server, right, and if two people make concurrent requests, you have to spawn two processes. If 10 dozen people are making concurrent requests, you have 10 dozen extra processes. It's tremendously expensive. Whereas with this DLL approach, you just enter another thread, another thread, another thread, another thread. If you want to return information, you blast it back and say, here's a pointer to the information I returned. You don't have to pump it the standard out and reformat it and catch it in a pipe and then get it out of the pipe and then put it back in a buffer and then transmit it. You just take it out of the buffer and transmit it. So of course that has a downside. If you write an unstable extension, then the server might have problems, right? I mean, so if it responds to some command you get, you call terminate thread or something like that, there's going to be a problem, right? It's not going to work too good, right? Whereas CGI, the process dies, IIS is very robust, right? I mean, it's got exception handlers and it's watching your thread and making sure you do stuff that's important and nice. And if you do something wrong and you cause a fault, we'll terminate that thread on you by calling terminate thread and pull the rug out of under you and you'll never run again, okay? So there is some stability, but it's certainly easy to cause problems with a bad design, is my point. Okay. So let's continue with our server-side thing. And specifically, let's talk about exactly how to write these guys. So MFC, it turns out, provides 5 classes, that allow you to write server extensions very, very readily. These are the 5 classes. This slide is intended to show. This slide is not intended to show, what is on this slide? CHTTP server, okay. So this slide is not, the indentation, don't get confused, this slide is not intended to show derivation. So by indenting this, I'm not saying that CHTTP server context derives from CHTTP server. And I'm also not trying to say you may or may not derive from all of these, okay? I didn't understand the slides. So, these 5 classes, and plus I should take a break here and point out that these 5 classes were written by me, which might change your whole outlook on how to write this kind of stuff. I mean, don't, maybe it's a bad thing to use. You're too kind. So you can use these guys. I mean, they might work, they might not, who knows. Multi-thread memory leaks, yes, whatever, is a hockey game, right? So what you can do is you can collect these guys, use a wizard to produce an application that uses them. They'll help you, they'll talk to each other. There's a little bit of infrastructure going on. There's an easy way to get all this stuff to work. Okay, and what we'll do is spend the rest of the slides talking about that. It's very important to point out that it is possible to use these classes without MFC. Right? These are MFC classes, but they live in a very, very separate static library. And if you want to use MFC in your extension, connect to a database, something like that, sure, fine, no problem. If you don't want to use MFC in your extension, don't link to MFC, just link to the library that has these guys. And unfortunately, the app wizard doesn't support hooking that up out of the gate in the app wizard. So it's up to you. You have to go read some comments and delete some stuff and change some headers and go from there to get a non-MFC ISAPI extension hooked up. Okay? Everybody understand that? Because if I hear anybody whining about how much overhead MFC adds to my server extensions, there's going to be trouble. Because you know what? You don't need it. Okay. All right. So these classes first appeared in MFC 4.1. They were updated to 4.2. Don't use 4.2. Use the 4.2b patch. That's old news. Updated to 4.2.1. Updated again in MFC 6.0. And probably there will be more fixes in MFC 6.1, which is something that I heard we might release sometime in the future, possible. Okay, so I mentioned that these guys have a couple distinct entry points, and of course MFC's job is to always translate from like flat API style things to things that you end up doing in C++. So what we need to do is translate from one of those flat API style entry points to a member function call on something that you can go override. Pretty simple, right? Which is why I'm a code monkey. I just take the same idea and like reapply it to different technology. Right? I don't know. How did I open the coconut? I hit it with a rock. Well, how do I open the banana? Hit it with a rock. So in get extension version, the idea there is to just say, look, I understand what version of the HTTP, or excuse me, the version of the ISAPI specification I was compiled with. Excuse me, with which I was compiled. Then I can say, look, I'm going to try to initialize, and I can compare that version with the version that the server is about to use, and I can make a decision about whether I want to run or not. And if I want to run, then I can run. If I don't want to run, I don't have to run. Then I can go and say, look, I want to take a name of my extension and put it in some special member data so that anything that my server extension does gets logged, right? Which is really important, because if you run a filter and it's like the filter's like saying, like getting your username and getting your Redmond account name and then putting it in the buffer and then using mapping to send it to Microsoft.com, then you might want to make sure that someone has some record of that actually happening. Of course, using the filter, you can also inhibit the log rights, which would be important in a security application like that. All right, so the idea here is that, look, here's an implementation of the get server version function. Get extension version turns out to take a pointer to this SE version info structure thing. And that guy has some fields in it. And what we'll do is call MFC first. And MFC will say, geez, let me check the version number and let me see what's going on. If that doesn't work, then we'll return false, which means that there's still an error on these slides. I've done this talk like 10 dozen times, and I still can't get this right. I'm like one of the shining stars at Microsoft. I know. So the thing that's going on here is, so what I did is I added a bang, right? If not HTTP server extension, get extension version, then we'll return false. Because otherwise, the way the code is in the handout, it'll successfully initialize, it'll return true, then you'll return false, and it'll never run, which would make for terrible demos. So then the next thing we do, if it's successfully initialized, I'm just going to say, well, look, let me go initialize the extension description guy with my extension name. I'll return true. In this function, it's a decent idea to initialize other stuff that you know you will need for the lifetime of your extension. So for the lifetime of your extension, you know, if you need a database connection or a pool of database connections or a couple extra worker threads or a big buffer of like 800 million megabytes or something like that, go ahead and allocate it here. And there's a sister function that will get called, and you can close all those things or free the memory, you know, if you so choose. I mean, maybe you just want to sit on the memory. I don't know. Lots of people do that. So the next thing that gets exposed is the HTTP server proc. And the HTTP server proc gets information about the actual request. So someone walks up to MoveBoy and says, whack register.dll question mark, and register.dll loads. Now, presumably register.dll was written with MFC, and register.dll exposes the real entry point, which turns out to be just the cDecl name, but not miscall, not anything like that, just a plain old HTTP server proc entry point. And we call that guy, and it gets information about the request. And that information about the request includes everything that's to the right of the question mark in the request. So if the user typed parameters, you get the parameters. If the user didn't type the parameters, you don't get no parameters, man. So HTTP server proc ends up being implemented by MFC, and what it does is takes a look at those parameters and tries to figure out what to do. What should happen now? So I have this parsing stuff in MFC that figures out, well, geez, which function should I call on your overridden HTTP server class? How should I find out what member needs to get executed? How do I format the parameters? What should I expect to the right of the question mark? What ends up being good format? What ends up being bad format? So on and so forth. Now the framework parses for a command in that data and figures out exactly what to do. It will go look for a matching command in a thing called a parse map that you will implement in your HTTP server object. Okay, so simple CGI commands and ISAPI commands look a lot the same. I mean, we tend to be doing the same thing, but it turns out that we've afforded the ability to add multiple commands in the same invocation, in the same module. So you can imagine that if I wrote this with CGI, I would be pretty much forced to, well, not really forced. I mean, I can implement the same mechanism, but most people who read CGI don't do this. They'd run off and say, well, look, I need to have a website that registers people. Then I need to have a website that also enrolls people. So I need two different DLLs. And certainly you're welcome to do that in MFC if you want to. But it's bad because you're making more DLLs, you're loading more things, you have more chunk in memory, you have the same overhead again and again and again, which adds up. On the other hand, what you can do in MFC is say, well, look, I want to have conf.dll, and I want to have after the question mark, the first thing I want to have after the question mark is a command. So I'll have conf.dll question mark register, and then after that, I'll start giving parameters. Otherwise, I'll have enroll, and after that, I'll start giving parameters. And if I want to, I can have more than one DLL. There's no problem running multiple DLLs on the server. Okay, completely clear? So I have completely clear if somebody blew his nose, right? So, it's nothing to see that. How do you code this in an HTML page? We'll see a demo of it in a few minutes. So what we'll end up doing in a parse map here is specifying what commands I want to execute and what parameters they take. So you can imagine that if I have register and enroll, I'll do things in my parse map that hook register and hook enroll to particular member functions. So in the declaration of my class, I'll need to add declare parse map. It takes no parameters. And if I, in my implementation file, in my CPP file, I'll end up having begin parse map and end parse map. So these two things will be class names. The first parameter will be the name of your class, C your class, or it could be C my class. I mean, if it's you can call it C my class, but if it's me, then I'm going to call it C your class, right? And then C base, right? C base will be the base class of the class that you're arriving from. And then again, we also need the name of the class here. It turns out that C base, these things can cascade. So you can implement some CHTTP server extension thing and then use it again in another project and multiply inherit, well, not really multiply inherit more than one level further down the tree. So C class might be hooked to C foo, and C foo might finally then be hooked to C HTTP extension. Okay, just like a message map, right? So remember when I said I just like reapply the same ideas to different things? Okay. Now the simplest kind of parse map entry provides absolutely no defaults. It says, look, I'm expecting no parameters, I have no information, I don't expect any parameters to be optional, so on and so forth. So let's talk about one of those first. If you have a command named myfunc in the server, C my server, you'll have this simple parse command entry, right? Myfunc will be the name of the function. So that's both what we expect to the right of the question mark in the URL and the name of the member function in the class C my server. Then after that, we start spewing things that are indicate the data types that we want to accept. Now this isn't a typo. This is one of the good slides. It turns out that there's a space here. There's not a comma. And the reason that's happening is because these guys turn out to be pound defined to strings. And if I want to specify more than one, I just end up, the preprocessor takes care of it, and I end up having some string, some string, some string. And when you have some string, some string, some string all next to each other in C++, they automatically get concatenated. International Sign Language for concatenated. Okay, so what that lets us do is just you kind of have a var_args macro, which you otherwise couldn't do, because that's what I would want here. It turns out that there's a bunch of different parameter types that you can specify here. ITS empty, ITS I2, I4, these are 2-byte and 4-byte integers. R4 and R8 is a float and a double, respectively. Pser is a pointer to a string, and raw, it's raw, get it? Very funny stuff. Ends up being, look, I don't have any parameters, just give me a pointer to whatever was sent to me. Don't parse it, don't touch it, don't do nothing, just give it to me. Bring it on, okay? So then it's all up to you, right? You get a pointer to it, you can parse variable length things, you can parse things out of a map, you can parse things whatever you want to do, okay? We were also going to implement, where are we, Denver? We were going to implement ITS I70, but there was just too much congestion. We were going to implement ITS your city here. Well, maybe this is fun for me, I don't know. Okay, so when you implement one of the functions that handles this guy, it always takes at least one parameter, even if you've done ITS empty. One parameter, a pointer to a CHTTP server context. And a CHTTP server context, since it's so easy to say, encapsulates all the information you need to know about the connection. It provides you some functions to write data back. It provides you some functions to get data from the connection. It provides you a way to remember the connection. It provides information about the headers that came on that connection. See where I'm going with this? Then you can use that guy to communicate back, or you can use that guy to find more information. You can use that guy to do whatever you need to do. Okay? So that's your lifeline back to the client. That's how you get back to the client. What happens in that function is entirely up to you. Okay, so you're implementing a C++ function. You can pump HTML back to the server context. You can pump binary data back to the server context. You can use the transmit file API on the server context to copy a file back there at super high speed. You can connect, you have an MFC connect to a database. You can not use MFC at all, whatever you need to do. Format the drive on the server, anything, right? This is C++. It's not some sissy server-side scripting language, all right? As a matter of fact, very many implementations of these functions will use things like pointers. Stock price better go up soon because I'm going to have to cash in. So here's a typical parse handler function, right? The parse handler function, this one's called register. I'm pulling on that example that we had, back earlier in the session. So I have my two parameters, right? I have HTTP server context, and then I have a lister to the name. Another thing I should probably fix on the slides, but this actually isn't enforced by MFC, so I won't actually call it a bug. I'll call it a suggestion. C++ is so easy, but PowerPoint is like confusing. This should probably be a pointer to a const string, because you're not allowed to go change that string, right? When you try to concatenate something to that string, kapow, right? It's over. So it probably should be const so that you can remember that it's const and you shouldn't touch it. But anyway, what ends up happening in this function is I compare the pointer that I get to a tilde. I look at the first character that I get, and I want to see if it's a tilde. And if it's a tilde, I'll set the return code bad request, and I'll pump back bad parameters. Otherwise, I'll say, hey, you're registered, and pass along the name that I got in that tilde parameter. And what you can estimate that I'm doing here is I'm saying, well, look, maybe if the user doesn't fill out the form and just jabs the submit button, maybe the default for this guy is a tilde. And by having a default for this guy, I can detect that data, and I can parse things, and I can figure out how to react appropriately. Otherwise, I'll register them. Well, actually, it looks like I'm not registering them. I'm just saying, like, you're registered and getting out of the function. So hopefully they print it out. The other point here that's really important to notice is this guy returns void. It doesn't return bool. It doesn't return an H result. It returns void. So it had better work. Okay, there's no room for failure. What ends up happening is that this function gets called, and this function must satisfactorily respond to the request. Satisfactorily responding, satisfactorily, I just got out of speed for training, ends up meaning that, look, you have to make some response, even if that response indicates an error. Okay, so from the point of view of HTTP, if you're putting information back, it could be okay or it might not be okay. So if someone registers and registers again, obviously that's an error to you, but that's your error. But you should still return an HTML page, and you still should return error code 200 for okay as far as HTTP is concerned. That way the browser will know, oh, I must have some HTTP data I'll see here, and you'll say in that HTTP data, error, you've already registered. Didn't want to register again, did you? So on the other hand, if you can't connect to the database, or if you're completely incapable of responding to the request, you might want to consider actually using one of the HTTP status codes. So and that's what I did here, right? So I said, look, I have a bad request. I'm going to use HTTP status bad request, which turns out to be like a 303 error or a 301 error or something like that. And I'm going to return that to the browser. The browser will not display what I specify here. Since I returned an error code, right, the browser says, well, look, there's an error code. I don't have any valid data to put back, so what should I display? I'm just going to display my stock error message for 303. That's what happens. So it's very important for you to understand semantically what should happen in that function, right? Make sure that you understand the difference between an error and not an error. So it turns out now we can yeah. The question was, why did I bother to put in the message? The reason I put in the message in the sample code in the slide was just to make the point that I just made. That's all. Right? It's like it's coding for political reasons rather than coding to get work done. Seriously, that's why I just wanted to talk about it, so I put it up there. So it probably should be commented out just to prove the point that it's not going to do anything. Okay. On parse command param ends up being a little bit more advanced message map entry. On parse command param ends up being a way for you to define parameters. So since we have this, we talked about on parse command So if I use these two macros in the server extension that I've written with MFC, the URLs at the bottom of this slide will actually invoke the function correctly. And this first URL will invoke the function with the pointer to the string pointing at Mike. And the second parameter will cause the integer value to be passed as 28. Now if I invoke this guy again with this lower URL, I'll get a name of Mike and an age of 0. So 0 is probably another error case that I could go check for in my code, right? And say, well, geez, no, nobody's 0 years old. Well, I guess, most people who register for conferences aren't 0 years old. Most people. So the thing is that, right, you can now structure this and you can provide default arguments. Now since I've named these guys, now also that I've named them, their order is now irrelevant. So if I didn't have this command param thing in here, I would always have to get the pointer to the string, ampersand, the integer. Now, with this guy here, I can say name equals Mike, ampersand, age equals 28, or I can say just plain age equals 28 with no name, or I can say age equals 28, ampersand, name equals Mike. So now they're order independent. There's a couple rules that dictate how order and optional parameters can coexist. The bottom line is that you can't have an optional parameter before a required parameter, both in the parse map and in the request. It won't work. And obviously, you can start finding some ambiguous situations. Is this a command, or is it a name, or is it a name of a command, or is it a name of a parameter, or is it the first missing parameter, or is it the second missing parameter? There's no way to resolve that, so we just don't allow it, which is really pretty easy. If you can't figure out how to code it, just make an assert and tell the user that something went wrong. So basic design philosophy behind MFC. Parse command default allows you to say, well, look, I want to have a default parameter. If I have a default parameter, a default command. So I want to have somebody execute something when someone walks up to me and says, geez, I just want to run register.dll question mark. Well, what happens? Well, the default param is what happens. The default command is what happens. So if I say parse command default myfunc, I can use this URL with myfunc in it explicitly, or I can use the URL without myfunc in it and name equals Mike. And we'll try to figure out, well, geez, is myfunc something that takes one string parameter? And if it does take one string parameter, we'll call it. If it doesn't, then I'll skip back and say, look, there must be some sort of error here. Now, the server context I kind of glossed over before we talked about the functions. The server context contains a C-HTML stream object. So every time you have a server context, it has a C-HTML stream member, all initialized and hooked up. And that guy turns out to be a memory buffer. It's just a glorified mem file. It's like C mem file. And you can put to it, right? You saw me use the insertion operators there, so I'm just dumping strings into it. And as I dump strings into it, it accumulates memory, and nothing else happens. When I return from my handling function, everything that's in that memory block, if my return was successful, gets blasted back to the client. That includes headers, that includes your response, that includes any data that you've tapped in. And the idea is to buffer those things up for a little while, because otherwise, if you just wrote to the client, wrote to the client, wrote to the client, you would do an individual network request for each of those right clients, which you'd imagine is pretty expensive for the nominal use of the class, right? If I walk to a database and I say, geez, get me a record, format it nice, give it to the client, get me a record, format it nice, give it to the client, that ends up being a loop that's pretty expensive, because every iteration through that loop hits the network and does a whole send to the network. Now, there are situations where you might want to do that, right? You might want to have something that takes a long time and write client back to the client right now and not block on it and say, look, your request is successful, I'm getting the data, ... Go get the data, work, format it, and then blast it all back all at once, right? And that's entirely possible, right? So you can mix the use of those two things. Other interesting members of that class include add header, which allows you to add a header and concatenate things to existing headers. You can see that I had an overloaded operator put to, insertion operator, that let me stick text and numbers and formatted stuff directly in to the stream. So I don't have to worry about calling wsprintf on every little thing I do. You can also call getServerVariable to get information about the server itself. So information about the server itself would include, the version of IIS that it's running, or its IP address, whereas header information is stuff that actually claims from the client, like the client's IP address, or the client's version of whatever browser they're running. Okay? Yep. Is the HTML class mumble like IO streams? Is that close enough? okay, so the question is it derived from the IOStream class? No, it is not derived from the IOStream class. So I did not derive it from the IOStream class for two reasons, count them two. One, the IOStream implementation that we have is terribly inefficient. It gives you like the OStream thing that we have right now, and this has probably been fixed. I guess I should look before I say this, but in version 5 and earlier, OStream would get to like a predetermined size, either the size you gave it in the constructor, like the default, which I think is like 2K, and then as you added more characters, it would add a character, reallocate for one more byte, add a character, reallocate for one more byte, add a character, reallocate, which could take time. The other reason I didn't use it was because I want these things to be lightweight. I want you to have the perception that you could write them without even using the C runtime, right? Which you can do right now, right? So if you can link to MFC itself for these functions doesn't use the C runtimes, and you can go ahead and continue there. So I want to save a little bit of weight, right? So if you want to use OStream, go ahead, right? I would check for that performance thing first, but otherwise, there's no reason to not add that on, okay? All right. So let's talk about filter support. Filter support just works in the same way HTTP support does. Instead of deriving from CHTTP extension, you're going to derive from CHTTP filter, create a static instance of your own class, just like CWinApp. You can override getFiltered version, and that is where you not only do you identify yourself, but you also express what things you're interested in seeing. So do I want a particular notification? Do I not want a particular notification? So on and so forth. I can override CHTTP filtered member functions to respond to those notifications, and then I make sure that I export stuff from the dev file so that everybody can talk to me. Now, we have a wizard that does all this stuff, and I'll demo that wizard in a few more slides. So the notification handling pushes receive information about the notification. So if the notification has some information for it, you can imagine the security notification gives you both the username and the password. However, the disconnection notification doesn't give you any data because you're disconnecting and there's really nothing you can do about it. All of these functions always receive a pointer to a CHTTP filter context. And CHTTP filter context is very analogous to CHTTP server context. It has the ability for you to query server variables, add headers, remove headers, pump data back, so on and so forth. So a typical override of these guys, all of these guys end up returning D words, and that D word indicates exactly what you want to have happen. So if I want to have end of net session, I'll end up getting filter context, and that's a pointer to the context, and I can touch that context and pump data back, or look at what happened, or figure out exactly what happened, or delete some data, or whatever I need to do on the end of net session. And when I'm done, I can say, look, just give this along to the next notification that needs to happen. And if I need that notification to proceed, to bubble up through the rest of the filters, this is what I'll return. On the other hand, you can imagine that if I wrote an authentication filter, and I didn't like the password that I got, I might return SF staticus next notification handled, which means that I handled it, don't give it to anybody else, it's done. And in that notification, if the password and the username were bad, I would probably indicate with an error message, you have a bad username, get off my web server. Okay? So this guy actually takes a pointer to a filter offense structure, and in that filter offense structure, you can imagine that there's a tchar array of characters for the username and for the password, and you can just go look at them. Okay. So let's start talking about the client side. Now, before I do the client side, let's have those demos that I promised. Okay? Do you like demos? Yeah. Okay. I just dream that an audience will someday say no. Then I just keep doing slides. Okay, so what ends up happening, let's see, so most of the time you'll start a project, let's call it test 2. So what I've done is I've gone and started up App Wizard, and I've clicked on iSAPI Extension Wizard. And iSAPI Extension Wizard turns out to be the wizard that generates iSAPI extensions. Yeah. Everybody complains that Microsoft technology is so complicated. I don't know what the deal is. All right, so for the project name, I'm just going to say test 2, and I'm going to drop it in a directory called Mike Blast, so that way other people can delete it later on. The first step, well, actually, let me go back here. I always like to point this out, too. See this little icon next to iSAPI Extension Wizard? I drew that. Yeah. Thanks. Thank you. So it's very, $8 billion company. You can't get a damn graphics artist to save your life. Well, of course, the graphics artist showed up, and we need actual real bitmaps, like this one. And that's way more talent than I have. There's letters in there and stuff. I don't think you could, well, actually, it does look like you could possibly draw that by combining two existing generate a server extension, or you can generate a filter object, and you must generate at least one. You can put both a filter and an extension in the same DLL. That's tremendously convenient, and it's actually a sneaky little trick so that you can get your extension preloaded. So if your extension has some very long initialization time, in other words, get version information has a tremendous amount of work to do, it's probably a good idea to create a filter just so that you can preload everything and get the initialization done. Otherwise, the first request made by a user will take a long time as your initialization runs. And we also implemented this beautiful user interface here that forces you to select at least one. I did that by responding to messages. Now here, I alluded to this earlier too. It turns out that you can link to MFC statically or link to MFC in the shared DLL. You're used to that. There should be a third choice here that says don't link to MFC at all. And because of, again, of limitations in the way the wizards work, we can't actually implement that yet, and maybe someday we will. If you generate either of these project styles, you'll find that you actually end up loading, you end up getting comments that say, here, delete this or delete that, or uncomment this or uncomment that to get rid of MFC. So that'll help until we get our act together and make a wizard that works. Now I'll go to next, and you can see that if I don't ask for a filter, I don't get a second step in the wizard. I'm also adjusting the number of steps that we have. So I'll ask for a filter, and this page here allows me to decide what's going to happen with the filter. And I glossed over some of these details in the slide, but let's really quickly go through them. It turns out that I can ask for high, medium, or low notification priority, and that means, well, geez, I want to be notified first, usually, or last in notification when compared to other filters. So if you request high priority and you're the only high priority filter, you always get notified first. If you request high priority and there's another high priority filter, you get notified in the order in which you were loaded. And the order in which you were loaded is the order that these extensions are actually listed in the registry or in the configuration manager for Internet Information Server. The other two checkboxes here, again, we use that snazzy must check at least one user interface. I should ask about a patent on this. I don't know if I can. That'd be pretty cool. Just impressed myself. So what ends up happening here is that you can ask for notifications on secured port sessions or non-secured port sessions. So non-secured just means HTTP, and secured means HTTPS. Meaning that, you want to see secure stuff or do you want to see non-secure stuff. Usually you ask for both, unless you're writing an authentication filter or unless you're writing a raw data filter, in which you probably only want to see one. Because raw data really is raw data. If you're doing it on HTTPS, you're seeing raw data, which is encrypted. So now all these notifications go on here. I can see incoming raw data or outgoing raw data. Incoming and outgoing mean from the point of view of the server. I can look at every single byte that the server receives or sends. So you can imagine these are very expensive notifications, right? You will see every single byte the server receives or sends. Every single byte. That is to say, all of them. Which can be, on a busy server, that could be millions of bytes a second. Computers are amazing tools for distributing information, and you can be in the way if you do this, and don't really need to. Post-pre-processing of the request headers turns out to be, the request headers come to you, and the server will smooth them out. And it will say, well, look, let me pre-process them. Let me take things that contain a URL and translate them to the logical URLs that I know about, and then let me pass them on. So if you want to wait until the server is done to see the request headers, you can look at this notification. Client authentication requests are authentication requests. Someone's making authentication requests with the authent posting. We have all that information built in there. Everything goes from there. We can do URL mapping requests, which are very similar. We can also inhibit or extend server log rights. So if I go ahead and finish this guy, I'm going to quit taking questions because we're running low on time. I can go ahead and finish this guy. Let me not generate a filter object for simplicity. And if I go ahead and build it, and while I'm building it, I'll dump into a directory test2 and debug. And you can see in the background that it's already built. So I have a test2.dll and a test2.pdb. And what I'll do is copy both of those files to the inetpub web root directory that I have. And what I'll do is run my Internet Information Server, get my server started. So now the server's running. And I can run back to my client machine. request test2.dll question mark, which will actually go off and run that extension DLL. And I just get the default message that was produced by the app wizard. Okay, that's all there is to it. So now I'm actually running code. So if I go back to the development machine that I have, which is also my server machine, let me stop the extension. Let me open a file here, have a look at it. Test2.cpp. Now you can see here, I got a default parse map, which doesn't really do anything interesting, right? I have a default command, and I'm saying that's the default command. I want to run it if nobody provides any command names. So I can also run, you saw me type in test2.dll question mark. I could also type in test2.dll question mark default, and it would still run this command because the default command still happens to be named default. And you can see here that I have my get version extension implementation produced by the wizard, nothing really exciting, and I have default here, and I just pump data back. And I can format it with HTML if I want to. There's a couple functions here: start content, write title, end content. Those write stock HTTP headers. So those will formulate an HTTP response. If I wanted a binary response, I would delete those guys and do my own add header work to indicate that I'm making a binary response. Okay. Let's have a really quick look at the client-side stuff. So all the client-side stuff implemented in MFC is implemented surrounding a system DLL called WinINet, WinINet.dll. WinINet wraps the three big protocols: Gopher, which is just huge, FTP, and HTTP. So now on the client side, you can use the classes that wrap this library to go talk to other servers. MFC has wrappers for all those guys. Again, we support it in 4.2, support it in 4.2.1. You should use the 4.2 pass if you're still in version 4.2. And we continue tracking the API in version 6.0 of the library. Everything requires WinINet.dll. So MFC just MFCizes, again, flat APIs that are exposed by this DLL. WinINet is an extension of the Windows API. It uses WinINet.dll. You need to pound include WinINet.h. That provides high-level implementation of all the common internet protocols. So by high-level implementation, I mean that you can go to an FTP server and get a file from an FTP server and disconnect without knowing how WinSock works, or how knowing that the FTP protocol works, other than, I need a server name and a file name to get something from an FTP server. So we covered Gopher, we covered FTP, we covered HTTP. Gopher is pretty much dead. I mean, I think like 0% of internet traffic is actually Gopher traffic nowadays. The support is still there if you have some legacy thing to go support. We support FTP and we support HTTP. So you can go out and make requests, go out and get the responses from those requests with the HTTP stuff, or if you're using FTP, go ahead and go and put files or get files or do whatever it is you need to do to the FTP server. On this slide, indentation does imply hierarchy. So we have all these classes, which again I wrote, so maybe they're no good. They all derive from each other as shown on this slide. And these guys wrap information about connecting to the internet DLL and connecting to servers and connecting and using files against those servers. There's also C internet exception, which is just along the lines of the regular MFC exception types. If one of these functions throws a problem, we'll throw an internet exception. You can get error from it to get an error message in English, as well as the error code, and so on and so forth. C internet session is the one thing that you need to do anything with WinINet. You must have one. This guy loads and initializes and configures WinINet DLL for some of the connections that you want. It is possible to use multiple copies of this class in the same application. Now you can see this guy takes a whole ton of options. The agent is the agent name. I think I have a slide for this, yeah. So the agent parameter turns out to be the name of your application, and it may be sent along in request headers to indicate who you are to the server. And that'll show up in the server log. That way you can know who you're talking to. And if you're writing an ISAP extension, maybe you'll look at the agent name and say, geez, is this an agent that I wrote? What version is it? How can I talk to it? Can I send back any special requests? When I send back a special response, do I use the version 1.0 response that I invented myself, or do I use the version 2.0 response that I invented myself? Responsible applications always fill this guy in. It just helps for tracking. It helps you on the server side. It helps network administrators. It helps everybody. So please use it. The rest of the flag parameters that we have give information about the semantics of the connection. And if you look at these guys, it turns out that they all resemble things that you would configure in the Internet Control Panel applet. And the Internet Control Panel applet just says, am I going to use a proxy? If I'm going to use a proxy, what's the proxy address? Do I skip caching for local, or do I skip the proxy for local addresses, so on and so forth. Now that information, you can say, well, geez, the default here is to use pre-configured internet access, which means forget about me setting any of this. Just go to see what's in control panel and use that. And that's what you probably should use for most of the applications you write. You might have more than one instance of this class if you want to communicate in two different modes. Maybe you always want to communicate to local guys with some different parameters that you specify here. Maybe remote guys get their own special parameters to optimize those styles of connections. So you can use multiple instances of this object to get out the door. And here's an enumeration of the flags that you can use. I just talked about pre-config. You can also use proxy to specify specific proxy information, or you can use Internet OpenType Direct, which means that you're not using the proxy, you're not using any pre-configured information, right? So Internet type pre-config just means use what's in control panel. Control panel might be direct or proxy. If you want to, you can specify direct or proxy directly yourself. You can derive also from CInternet session. CInternet session allows you to override on-status callback to get information about things that are happening on the connection as they happen. You can update user progress information accordingly, put something in the status bar connected to the server, getting data from the server, resolving the request from the server, returning from the server, reading bytes, disconnected. Those are the styles of notifications that you can use there. Some documentation someplace says that to do this you need internet flag async. That is not true. MFC does not support internet flag async. It's not required to get these callbacks. So now CInternet session is the parent class for a lot of other classes. Get FTP connection, get HTTP connection, get Gopher connection. And you can imagine each of those guys take parameters. What server do you want to connect to? What port on that server? What password and username do you want to use to connect to that server? And when those functions return successfully, they get you a pointer that you can later use to go talk to that server. And from there, work gets done. That's how you talk to the server. We also have an abstraction called OpenURL, which will just take a plain old URL string and return a polymorphic CInternet session object, or CInternet file, actually, object, that will let you get the data from that particular URL. So if you don't want to do any parsing or any decision making yourself, OpenURL is the one for you. So now each of these classes, we sort of outlined a function, a hierarchy. There's a session, and under the session are connections, and under the connections are files that you're using on those sessions, in the connections on the sessions. That hierarchy exhibits what one INET does for options. It's possible to walk up to any level in that hierarchy from the session to the connection to the file and set some options. And the options include things like, how do I do translation? How do I wait for timeouts? Do I wait for retries when I have a timeout? How many retries do I do? Is there a pause between retries? So on and so forth. Okay? So all the options get inherited. So if you set the timeout option for the whole session, it affects the connections and the files. It is possible to set an option only for a particular connection or only for a particular file. Just remember that those options get inherited as new objects are created off of whatever you set them on. AFX parse URL will help you parse a URL and get components of it. So you can provide a URL, find out the service type, the server, the object, and the port number that was specified in the URL. This is not connection-based validation. It's also not spelling-based validation. If you specify a totally bogus server name and we don't know that server exists or not, we're still going to say that looks like a good URL to me. It's a good URL syntactically, but semantically it might not be. So you might have to actually try to connect to it before you end up getting a failure. AFX parse URL EX is the same function, but it accepts a few extra flags. It'll handle encoding and a thing called browser mode, which helps you worry about encoding, right? We'll skip Gopher connection. What do you think? Yeah. Okay, experience FTP connection. Directory operations on CFTP connection include, getting or setting a directory, removing or creating directories, getting a file, removing a file, putting a file. Now, when I say those file operations, a file operation in this context just means, look, I have the name of a local file, I have a connection to a server, and that server connection has a current directory, and that current directory, I want to put the file onto that server with a given name. So you can imagine put a file or get a file. It just says, look, local name, comma, remote name, copy the whole thing. That's it. Or remote name, local name, copy the whole thing. If you want to open a file or read through it line by line, you can also do that. Party on it later, use read write, use whatever you want to spew data or get data. C file find, which we've also added to MFC pretty recently. We have some derivations from that guy as well. We have Gopher file find and FTP file find, which means means you can enumerate things that are on a Gopher server or enumerate things that are on an FTP file file. Sorry, on an FTP server. So they're pretty simple. Find file and a name, call find next file in a loop, and then during that loop, call functions on file find to get attributes. What's the URL of this guy? What's the last update time of this guy? What's the file name for this guy? What's the current directory? So on and so forth. And here's a list of all the attributes, and you can read them just as fast as I can. It's really important to remember the loop is done in the style of MFC's position style loops. So while you're working, if I find a file and I'm working, I'll continue while I'm working. I'll call find next file. And I have to call find next file once before I can start calling any of the attribute things. Okay? And if you think about the way you would enumerate a list or an array in MFC, same thing here. It's the same style of the MFC enumerator. The C internet file derives from the C standard IO file. You can read and write to it. You can read string and write string if you know that you're doing an ANSI transfer. Otherwise, read and write are pretty much oriented for binary transfers. If you want to, you can make it buffered as well. So MFC will do buffering before it actually calls the API, which can be very handy depending upon the mode you're reading or writing to the file in. Some things are not fully supported. So even though we derive from C standard IO file, there's C standard IO file thingies that just don't work. You need to be able to, you can't duplicate an internet file handle. You can't seek on a file handle, so on and so forth. Obviously, locking is not available. The CHTTP connection is the most interesting one. We'll spend a little bit more time on it. So you call CHTTP connection, then you open a request. You specify a verb, and you can say get. Remember when I used telnet and I said get slash? I could also say post slash or link slash or unlink slash, any number of verbs. And since you're writing your own HTTP extensions with INET, with ISAPing, you can implement your own verbs if you'd like. Specify the object in that call, and then it'll return a pointer to a CHTTP file object. CHTTP file object is not yet initialized. You need to actually send the request. So when you send the request, then the file is actually open if it was handled successfully. Now, handled successfully just means that we connected to the server, and the server made some response. Sent request successfully open might mean that I've connected to that server and end up with an error response. And that error response could come in the form of HTML. So once that guy is sent, I can do query info or I can do read on it to find information about it. Query info gives me access to the headers. Read gives me access to the actual data. So let's do a really, really quick demo of how all that stuff works. And we have only a couple more slides. We'll do a demo, an MFC sample called tear, or you can call it tear if you wanted to. And what we'll do is pop open. It has a single source file, so it can't be that complicated at all, right? And the idea behind tear is that, I'll just run it from the command line really quick here. And if I go to debug, tear http://www.nhl.com. Okay? And what this guy will do is run off using the WinINet classes and go to nhl.com and request the URL that I requested here, just plain old nhl.com, get the raw HTML, and print it out to standard output. And that's all there is to it, right? But it's a very interesting program because you can see exactly how we do all this stuff, right? So the first thing I do is take what I get in the command line and try to parse it into a URL that I can use. And if it's a bogus URL, I'll make an error and throw an exception. If I turn it on progress mode, I'll start printing information about the progress that I'm getting because I'm using enable status callback. Otherwise, I'll just show the main loop here. I'll get an HTTP connection from to the server name that I parsed out on the port that I parsed out. I'll open the request asking for the verb get on the object that I parsed out, and I won't use any of the security parameters. And I'll use some request flags. The request flags that this program uses are just request flags that say, look, always fetch it. Don't let it come from cache. Always hit the server, which is why it was so slow. You can imagine that on this machine, since I was using this machine, NHL.com is in cache. But I went out and got a different copy of it anyway. So I want to add request headers, and then I want to send the request. It's only after I send the request is p-file usable. So what I start doing now is call info query status code to try to see what the request was. And if it's status denied, then I start doing UI to get a password from the user. Otherwise, I get information about the raw headers, see if my request is redirected, and if it's redirected, I handle the redirection myself. Otherwise, now that I have this file open, I just plot through it. Read string, I buffer. If I'm stripping character terms and line feeds, I strip them, and then I just stick it out to the user's output. So if I put a breakpoint here, you'd see every single line of HTML going by, going by, going by, going by. Okay? It's a very, very simple sample. Make sure you just go home and spend some time with it and read it and make sure you understand it. Clearly demonstrates exactly what's going on in all the classes. 2 more slides, we're out of here. Okay? Okay. Anybody got a plane to catch or anything? Now I can do. Okay. So one of the things that we've enhanced in MFC is a class called CHTML_View class. Now, so what I've talked about up to this point in the talk is like, look, how do I write servers? How do I write clients? And I'm dealing with raw, low-level stuff. But you can imagine that an internet client might exist at a little bit higher level. Maybe it connects to the internet and does some work with pages and shows the users pages and stuff like that. Well, what I've done is put a sample on the client on the conference CD that demonstrates a way to use CHTML_View, which is a view class in MFC now. And CHTML_View, as you can imagine, contains HTML. So what ends up being in the client area of that view is just plain old HTML. But that class also gives you access to the document object model for Trident, which you've learned about in other places in other sessions in this conference. And that guy, once you have a pointer to that guy, you can start parsing things that are actually on the web page, or look at things that are available in the response that you get, and deal with things that are coming back from the server. It's also possible to implement an automation interface in MFC in your client-side application. And that automation interface might expose automatable objects from your MFC client, which is containing an HTTP page, an HTML page, and that HTML page in turn contains DHTML or contains script. And in that script, you can write window.external.someMFC object and call methods on it. It's very, very exciting. It's a very interesting programming model. Because the idea is that, well, look, I have something that's coming down to me in the form of DHTML and script that I can look at and use and get something done with in a plain old browser. But now, if I don't have a browser and I have my powerful MFC application, I can start wadding up an automation interface and make an application hierarchy that I expose from my application that actually gets driven by a script. And if I need to update what that guy does, I just update the script and download it to the client. And the client exposes those objects and lets me move those objects around. It's a very, very exciting programming model. And in future versions of Visual C++ and MFC, I think you'll see it enhanced greatly so that we can continue to support the DHTML wave that's coming from Microsoft. This programming methodology works in the holder sample, which again is on the CD. You use HTML_View, load what's in HTML_View, then you can have objects in the HTML, do window.external and touch things that MFC has exposed. In HTML, it's very simple as well. Use the DHTML control and then expose an automation interface off the root object. Same thing. Very, very straightforward, very, very easy to do. So here's a slide about finding out more information. Please look at these URLs. Again, let me stress the CGI documentation, the INET standards documentation, the HTTP documentation. Imperative to use it if you're handling your own clients and your own servers and stuff like that. Make sure you're up to date on the RFCs. Make sure you understand what they're explaining to you and how this stuff would work. That teaches you how to react to different servers, different things, error conditions, different clients, and so on and so forth. And that covers it. So what I'll do for about 5 minutes, because I have to give the room up, is take questions really, really quick. And if you could, use either of the 2 microphones. Okay? Thanks a lot. Thank you very much. Okay. And also I'm asked to please exit out the front door on this side over at the front of the room. For traffic control, I guess. It sort of sounds like the microphones aren't on. Maybe that's a hint for me to get out of the room. Oh, okay, there we go. So what I'll do is I'll take 3 questions, and after that, I'm out of here. You can chase me into the hall and corner me in the hall, and even though I have to go to the bathroom like really bad, I'll answer questions for you.
Could you just talk real quick about how to debug an ISAPI extension?
So really quick, how to debug an ISAPI extension. Turn your attention to these beautiful projection screens. And what I'll do is load one of the projects that I was working on before. And you'll see the project comes up, project settings, general. What I do here is point at, in the general, point at inetinfo.exe, right, which is the INET Information Service Manager, and I give it the option EW3 service here, okay? And that tells it to kick off the web server. So now I have the web server running as a client application under the debugger. Additional DLLs, I load the DLL that's under test. I load the DLL from my project. Okay? I don't have help installed on this machine, but if you browse the technical notes, you can find explicit instructions that enumerate that. The instructions are also very different for Internet Information Server 4. And we have an update to those instructions in the tech notes as well. I think Dan, are you here? I saw you out there. You don't know the number of the tech note offhand, do you? No? So it's like tech note 57 or tech note 63, something over 55. So if you just browse through those guys, you'll see how do I debug an INET extension. We have one more question, and then you'll have to chase me out in the hall.
Can you talk something about a distribution of the HTML controls for clients that do not wish to install Internet Explorer for root?
Can I say something about the distribution of Internet controls for clients that don't do what?
Do not want to install Internet Explorer.
Okay, so if you don't want to install Internet Explorer, you're kind of out of luck as far as I know. I know that Netscape is supporting a version of the HTML standard. After that, what to do practically, I really have no idea. So it's sort of out of the scope of my expertise, sorry. Okay, hey again, thanks for coming. Please let me pack up and get out of the way of the next speaker, and I'll meet you out in the hallway if you have more questions. Bye.